Alright, so here's the last example for this section, the very last one. And hopefully this is one of those that everybody understands and gets, because we're kind of going back to the money problems. So those types of problems. So we're talking about compound interest here, but we're going to go backwards a little bit because we're solving exponential functions. An exponential function. And we're possibly going to do a word problem also for logs, because I just want to make sure you have that too. So this might not be the last one. Let me take that back. It might not be the last one. But looking at what's best for you guys. So here, exponential function here, and it's talking about the money. So this formula, and let me go ahead and give you the whole thing. And again, if you want to stop the video at this point and write down all this, you can write it down really quickly and then I'll read through it. So I'm going to pause it and I'm going to stop. Okay, so we've talked about this and you see it now. So what I want you to do, or what we want to try to do, is try to figure out this problem. So they give you the formula again of the compound interest, and here they tell you exactly what everything is. We know that A is the accumulated value, or the value you have at the end of the amount of time that you're putting the money in there. So at the end of 5 years, what amount of money you have. We know P is the principal of what you put into the account. We know T is the number of years. We know R is the rate that they give you, and we're going to change that to decimal form. And we know N is the number of times the interest rate is compounded a year. So what we're trying to find as the question is, how long will it take $25,000 to grow to $500,000 at 9% annual interest compounded monthly? Okay, so we already know the formula. We already have that. But again, remember, they do not give you this formula ever when it comes to the final exam or even in class, like for tests and stuff. So you're going to have to remember this formula. You have to remember it. And it's not a bad formula to remember, but it comes up and it's going to pop up multiple times. All right, so before we go ahead and work out the problem, let's go ahead and pull out all the parts that we need. Let me change that to blue, so I think blue will look better. Yeah, so we have A, we have P, R, N, and T. Okay, so if we take a look at that last part they gave us here, we know that A is the amount that you have at the very end. So if we look at that, is A going to be 25,000 or 500,000? 500,000, right? Yeah, you're amazing. So that's 500,000 is what we're going to end with. So that's what our A is. That's what we're trying to get to. So how much are we putting into it? 25,000. You're right. Yeah, y'all. You guys are smart. Very smart. Very smart. All right. What is our rate? Our percent. So it's 9% here. And that's 0.09. So again, we just talked about these three parts here. So this is what A is. That's A. This is our P, our principal, we put into the account. And this is our R, the rate. Let's do a lowercase r. That's our rate. All right. And so N is also possibly given to us in here. So an annual rate of interest, annual interest compounded monthly. So it says compounded monthly. So what does monthly mean? What does monthly mean? How many months in a year? 4, 12, 365, 17, 2. There are 12 months in a year. So that is our N right here. So it's 12 months in a year. So N is 12. And what does the question ask again? How long will it take? So talking about how long, that's time, right? So that's our T. That's how long, our time. So we don't know how long it's going to take, so that means we don't know what T is. So that's going to be our question mark right there. So we'll leave that there because we don't know what it is yet. And we're going to find it though. So that's what the math's all about. So it's going to fill everything in here. Oops. I'm going to fill in the 500,000 for A. The 25,000 in for B. For P, sorry. the 0.09 for r, the 12 for n, and then 12 again for the second n, and then we leave the letter t there. All right, and so our goal, again, is to get t by itself, or get that variable by itself. So it means we have to get everything else over to the other side and get that by itself. So we got to figure out, again, what is our exponential function? So we start off with step 1, isolate the exponential function, isolate it. So here, this is this whole part right here is our exponential function. So that means we need to get that 25,000 to the other side. So let's go ahead and divide by that 25,000. And if you notice, I didn't write the word exponential function again. You can if you want to, but I just didn't do it because I don't really have a whole lot of space there. And I think by now you guys should be able to see that and understand how to find that. So I'm not gonna write that word out there. Don't let it mess with you. Don't let it freak you out. All right, so just rewriting everything so it looks better. Some of you are like, well, why can't we just divide this part here because there's too much writing? Just leave it. Leave it as it is. It's going to be okay. Just leave it as it is. All right, so here what we can do, though, is get rid of some zeros because we have it behind on the back. So we can get rid of these zeros here. So we're kind of really looking at 500 divided by 25. So let's make it a little bit smaller. All right, so then the first step was isolate. What's the next step for exponential functions? Let's write it. Natural log it. Natural log it. Natural log it. All right. So step 2 is to natural log both sides. So let's do natural log both sides. Natural log it. Natural log it. Natural log it. We have the 12t as your exponent. All right, and then at that point, let's do natural log. All right, so after that, now we're dealing with step 3. And hopefully everybody remembers what step 3 is. Yes, we go ahead and use one of those rules. Simplify it down. Simplify it. Use one of those rules. And we only had either the E rule or we had the power rule. And here, is there an E in there at all? No, so it means we need to use our power rule. In other words, take that and put it into front. And this should actually be pretty quick and easy now because we can move everything over to the other side by it's like in one swoop, and then we're about done. We is done. So let's go ahead and solve it out, and then we'll be done. So solve is the last one. So here, that is 12 times t times natural log of all that great, wonderful information back there in the parentheses. So if we're multiplying here and trying to get t by itself, remember we do the opposite. So we divide by that, all that wonderful stuff. So we leave the t alone. Do not divide by t. And hopefully everybody sees there's a difference between my t and my addition sign, because I don't want my t's and my addition signs to be mixed up. So that's why I do that little curve right there. So it doesn't look like the t. And you're more than welcome to do that if you want to. If you don't, it's okay. I'm not going to make that mandatory and you have to do it my way and blah, blah, blah. All right, so we divide both sides by that so we can isolate it. So bam, bam. All this wonderful information there is gone on that side. So we're left with just bam, t. All right, and then we go ahead and put all this wonderful information right here. I reckon. All right, so let's go ahead and put that into the calculator, and then we're done. That's all it is. We're going to tell us how many years it is. We just got to make sure we write the answer in a sentence because they gave us a word problem, so we need to make sure we write it so it's not just numbers, but it actually has meaning. Number is so important that we write down things and explain things because They have meaning. It's not just random numbers. It's real life. All right, so at this point, I'm not going to explain how to put all this into the calculator. You should be able to do that by now. So I'm not going to do that for you. So I want you to go ahead and put it in the calculator and find the decimal answer. And again, we're talking about years, so we're going to end up rounding it to a whole number because we can't have like a part of a year or like a 3/4 of a year or some of that sort, or not 3/4, like 3.4 of a year. All right, so everybody should have gotten about 33.411 years, about that, approximate. So I'm going to go ahead and round that to just 33 years. It's going to take a little bit over 33 years, but about 33 years. I'm going to write that in a sentence. $500,000. So it will take approximately 33 years for $25,000 to grow to $500,000. So it's not bad. That's not a bad thing. So we know how to do this also this way. So if I give you a word problem like this, you should be able to know how to do it. If you have questions again, don't hesitate to ask.